Hello everyone, welcome to the next part of derivative. In this class, we will discuss the derivative of parametric functions. So first of all, how the parametric function look like. So in case of parametric function, both the value of x and y that will be given separately like this. Okay. So how to do the derivative? So let's consider x is given in a function of variable, let's say t, and y is given the function g in terms of variable t. Okay, either the variable mostly t or theta will be there. So variable is here t, so we'll take the derivative with respect to t. So derivative of x with respect to t, that can be written as dx by dt. Okay, and in this set, let's say f dash of t. Similarly, y is given, so if we take the derivative of y with respect to t, so we'll get dy by dt is equal to g dash of t. Then to find out dy by dx, this is the last step. To find out dy by dx, we will divide the derivative of y to the derivative of x. So we'll get our answer. So look at the question, find dy by dx, where x is given to be at cube and y is given to be 2at. Okay, so in x and y both are in terms of variable t here, and this a is nothing but a constant term. So if we take the derivative of x with respect to t, that will be dx upon dt, derivative with respect to t. This a is a constant, and since we are doing the derivative with respect to t, so derivative of t raised to 3, that will be 3t raised to 2. Okay, so if we multiply it, we'll get 3a t square. Similarly, y is 2at, so if we take the derivative of y with respect to t, we will get dy upon dt. So this 2 into a is constant, that will be as it is, and derivative of t with respect to t, which is 1. So we are getting 2a into 1, which is 2a. Okay, so the final step, we have to find out dy by dx. So dy by dx is nothing but derivative of y, which is 2a, divided by derivative of x, which is 3at square. Okay, so this a and a we can cancel out, so the final answer will get 2 upon 3t square. So this is our value of dy by dx. Look at the next question. So x is given a cos theta and y is given b sin theta. We have to find out dy by dx. Okay, so first of all, let's write whatever is given. So x is equal to given a cos theta. So here this a is a constant and y is equal to given b sin theta. Okay, so here this b is a constant. So in both the term x and y, the variable is theta here. So we have to take the derivative with respect to theta. So derivative of x with respect to theta, that will be dx upon d theta is equal to a is a constant, derivative of cos theta, which is minus of sin theta. Okay, so if you multiply, we'll get minus a sin theta. Similarly, if we take the derivative of y with respect to theta, we will get dy upon d theta is equal to b is a constant, derivative of sin theta, which is cos theta. Okay, so the last part, dy by dx. So dy by dx is nothing but derivative of y with respect to theta divided by derivative of x with respect to theta. So we have to divide both the derivatives. So what is the derivative of y with respect to theta? B cos theta. And in the denominator, derivative of x with respect to theta, which is minus a sin theta. Okay, so this minus of b upon a as it is cos theta upon sin theta, which is nothing but cot theta. So that's our final answer. Look at the next question. So the next question is x is equal to sin t, y is equal to cos 2t. Find dy by dx. So x is equal to sin t, so variable is here t. So if we take the derivative of x with respect to t, we will get dx upon dt, derivative of sin t, which is nothing but cos t. Okay, so that's the answer. And other side, if we take the derivative of y with respect to t, so dy by dt is equal to derivative of cos 2t, which is minus sin 2t. Okay, multiply by, we have to do the derivative of 2t also, so derivative of 2t, which is 2. So we have to find out dy by dx. So dy by dx is nothing but derivative of y with respect to t upon derivative of x with respect to t. So substitute the value. So derivative of y is minus sine 2t into 2. In the denominator we have derivative of cos, which is x, which is cos t. Okay. So if you want to solve further, this minus sign as it is, sine 2t. So if you apply the formula of sine 2t, okay, the formula of sine 2x, that we have 2 sine x into cos x. So minus sign as it is, sine 2t means 2 sine t into cos t, and multiply this 2 is there extra, that is as it is, upon cos t. So this 1 cos t will get cancelled, and if we multiply this 2 into 2, it will be minus 4 sine t. So that's our final answer. Look at the next question. So the next we have x is equal to 4t and y is equal to 4 upon t. So variable in both the cases is t. Okay. So x is equal to 4 times t. So if we take the derivative with respect to t, we will get dx upon dt is equal to 4 is a constant, derivative of t which is 1. So we will get 4 answer. Other side y is equal to given 4 upon t. Okay. So if we take the derivative, so we will get dy by dt is equal to 4 as it is, and the remaining part is 1 upon t. Okay, so the derivative of 1 upon t, which is nothing but minus 1 by t square. Okay, so the final answer will be 4 into minus 1 minus 4 upon t square. You can remember the derivative of let's say 1 upon t as a formula, that is minus 1 upon t square. Otherwise you can derive t means t raised to 1 if you take in the numerator t raised to minus 1. So if you apply the formula derivative of t raised to n, you will get this answer. Okay. So the final step, dy by dx. So dy by dx is nothing but derivative of y, which is minus 4 by t square, upon derivative of x, which is 4. So this 4 and 4 will get cancelled. So it will remain minus 1 upon t square. That's our answer. Look at the next question. So next we have x is equal to cos theta minus cos 2 theta and y is equal to sin theta minus sin 2 theta. So variable is here theta. So x is equal to given cos theta minus cos 2 theta. So if we take the derivative with respect to x theta, that will be dx by d theta is equal to derivative of cos theta, which is minus sin theta, minus derivative of cos 2 theta, which is minus of sin 2 theta, multiply by derivative of 2 theta, which is 2. So if we simplify, we'll get minus sin theta. This minus minus getting plus sin 2 theta into 2. Okay. Similarly, we can do the derivative of y. So y is equal to sin theta minus sin 2 theta. So take the derivative with respect to theta. So dy by d theta, derivative of sin, which is cos theta, minus derivative of sin 2 theta, which is cos 2 theta, multiply by derivative of 2 theta, which is 2. So we will get a cos theta minus 2 cos 2 theta. Okay, this 2 we have written here. So the final step, dy by dx. dy by dx is nothing but derivative of y with respect to theta upon derivative of x with respect to theta. So derivative of y is cos theta minus 2 cos 2 theta upon derivative of x is minus sin theta plus 2 sin 2 theta. So this is our final answer. Look at the next problem. So the question is x is equal to a bracket theta minus sin theta and y is equal to a bracket 1 plus cos theta. Find dy by dx. So variable is theta. So if we take the derivative with respect to theta, so dx by d theta is equal to, now this a is in the multiplication with this bracket. Okay, so we'll write down a as it is, bracket derivative of theta. So with respect to theta we are doing, so derivative of theta is 1 minus derivative of sin theta, which is cos theta. Then other side, derivative of y with respect to theta, which is dy by d theta. A is as it is because it is a multiplication, bracket derivative of 1, which is 0, plus derivative of cos theta, which is minus of sin theta. Okay, so we can write down as a 0 plus minus minus sin theta. So that we can write down as minus of a sin theta. Okay, so if we find out the answer, dy by dx, so derivative of y in the numerator, which is minus a sin theta, upon derivative of x, which is a bracket 1 minus cos theta. Okay, so now if we apply the formula to solve further, so in the last class I have given the formula of 1 minus cos theta, 1 minus cos and theta. Most important formula it is 1 minus cos and theta means 2 sin square and theta by 2. Okay, and the another formula is in terms of sine of n theta. Okay, these are the in general formula. Sine of n theta can be written as 2 sin n theta by 2 into cos n theta by 2. Okay, so you'll apply these formulas here. So in the numerator, this minus a as it is, here it is given sin theta, so n is here 1. Okay, number is not there, that means 1. So sin n theta means 2 sin n theta by 2 into cos n theta by 2. So sin theta can be written as 2 sin theta by 2 into cos theta by 2. In the denominator, a as it is 1 minus cos theta. So 1 minus cos n theta formula is 2 sin square n theta by 2. So that can be written as 2 sin square. Here also n is 1 because angle is only theta, that means 1 theta. So we have to write down the half of that angle, that means theta upon 2. Okay, so this a and a will get cancelled, 2 will get cancelled, 1 sin theta by 2 will get cancelled. So what will remain? Minus sign in the numerator into cos theta by 2, and in the denominator sin theta by 2. So cos upon sin, which is nothing but cot, with minus sign, so minus cot theta by 2. That's our final answer. Look at the next question. So x is equal to given a sec theta and y is equal to given b tan theta. So variable is here theta. So if you write derivative of x with respect to theta, which is dx upon d theta, is equal to a is a constant as it is, derivative of sec theta, which is sec theta into tan theta. Another side we have y is equal to b tan theta. So derivative of y with respect to theta, which is dy upon d theta, is equal to b as it is, and derivative of tan, which is sec square theta. So our dy by dx value will be in the numerator derivative of y, which is b sec square theta, and in the denominator derivative of x, which is a sec theta into tan theta. So 1 sec theta will get cancelled. So what will remain? B sec theta in the numerator divided by a tan theta in the denominator. Okay, so we can solve it further. B upon a as it is, sec theta can be written as 1 upon cos theta, and tan theta can be written as sin theta upon cos theta. So this 1 cos theta will get cancelled, and 1 upon sin theta can be written as cosec theta. So our answer will be b upon a, and 1 upon sin means cosec theta. So that is the value of our dy by dx. Look at the next question. Okay, so next question is x is equal to given a bracket cos theta plus theta sin theta, and y is equal to a bracket sin theta minus theta cos theta. Okay, so let's start with the derivative of x. Variable is here theta, so our derivative with respect to theta will be dx upon d theta is equal to, this a is a multiplication with this bracket, so a is it is bracket, derivative of cos theta which is minus sin theta, plus, now in the second term if you see properly, theta sin theta, so it is in the multiplication. Okay, this is one term, sin theta is another term. So to the derivative we have to do, we will use UV rule. So let's consider this theta is u, sin theta is v. Okay, so theta as it is, derivative of sin theta. Okay, I have not done the derivative, just apply the formula first, plus second time sin theta as it is, and derivative of theta. I have written dash, dash means derivative. So a as it is minus sin theta plus theta as it is, derivative of sin theta which is cos theta, plus this sin theta as it is, and derivative of theta. So we are doing derivative with respect to theta, so derivative of theta is 1. So if we solve this bracket, we will get a inside the bracket minus sin theta plus theta cos theta plus sin theta into 1 which is sin theta. So inside this bracket minus sin theta plus sin theta, so that will be 0. So a into theta cos theta, only this term will remain. Okay, so this is the value of dx upon d theta. Now let's solve the another part, y. So if we do the derivative of y with respect to x, we will get dy by d theta is equal to a as it is bracket, derivative of sin theta which is cos theta, then minus, here also we have to apply UV rule because it is a multiplication. Okay, so after minus always write the bracket. Okay, because this minus sign we have to multiply with each term, so we will put again one more bracket. Okay, theta as it is, then derivative of cos theta, so I have written dash, then plus cos theta as it is, and derivative of theta dash, bracket close. So a outside as it is bracket, cos theta as it is, minus bracket, we have to solve this derivative, dash means derivative we have to solve first, theta as it is, derivative of cos theta which is minus sin theta, so again one more bracket, plus cos theta as it is, and derivative of theta which is 1. So a bracket cos theta as it is, so if we multiply this minus sign inside, so here minus minus getting plus theta sin theta, and this sign we have to multiply here also, so minus plus getting minus cos theta into 1 which is cos theta. So if you look at in the inside the bracket, cos theta and minus cos theta, so that will become 0. So a into theta sin theta will remain. Okay, now our final step, which is dy by dx. So dy by dx means derivative of y, which is a theta sin theta, divided by derivative of x, which is a theta cos theta. So this a and a will get cancelled, theta and theta will get cancelled, sin theta upon cos theta, which is nothing but tan theta. Okay, so our answer of dy by dx is tan theta. So this is all about derivative of parametric functions. Thank you.